All right. Good evening, everyone. Welcome to the talk. It's great to be here at KubeCon, and especially since it's the first time this event is happening in India, I'm really excited to be part of this amazing event. And today we're going to talk about something that might just change the way you think about Kubernetes pods. So before I delve into the actual content, let me introduce myself. I'm Sohan Kunkerkar. I work at Red Hat as a senior software engineer. I'm one of the CRI-O maintainers. It's a CNCF project for container runtime interface, and part of the SIG-Node community, which predominantly works on kubelet node-specific projects. If I'm not working, I'll be either playing flute or doing trekking or other outdoor activities. So here's the agenda for today's talk. We'll be quickly covering the introduction to pods. Then we'll understand the real-world demands and aspiration for the pods. Then we'll understand how nested containers will satisfy some of the demands from the users. Then we'll see some of the examples, followed by the limitation in the current pod model. Then we'll also see some of the upstream Kubernetes efforts that we are doing to make nested containers truly a native container Kubernetes solution. And then towards the end, I'll open up for questions and answers. All right, so many of you are already aware about Kubernetes pods, so I'm not going to spend much time on it. It's going to be brief. So pods are nothing but, it's the smallest deployable unit in Kubernetes and a basic building block for deploying applications. So you can think of pod as a logical host which has multiple containers which shares the same network space and storage volumes. So this makes us a perfect use case for hosting microservices architecture and sidecar pattern. Pod excels in tightly communication and storage volumes for containerized apps. When it comes to security and isolation, pod isolates workloads at a little higher level, enable resource sharing for containers within the pod. Now, while pod is versatile enough, the modern demands are actually pushing the boundaries for what they can achieve today. So developers, operators need more flexibility, tight security, and more capabilities. So let's understand some of the use cases that users are demanding from the pods. One of the best and frequent use cases for user is running containerized tools like Podman, Builder, CRI-O, Builder inside the pod. So think of it as CI/CD or the local deployment, where they want to integrate these tools very natively within the Kubernetes ecosystem. There's also need to behave certain workloads in a virtual machine-like way, where users want the isolation of virtual machine. At the same time, they want to retain the flexibility for the pod. There are few users who want to actually build certain nested environments, like the pod within pod. And in order to do those kind of stuff, they want to really mimic the application inside the pod. And last but not the least, but very important factor, is the security. Privileged workloads are risky. So there's a need for secure, rootless containers with privilege escalation taken into consideration. Now you can see here the demand, like what pods can achieve today and what modern workloads are required. So there's a huge gap there. So nested containers is one of the solutions that we are going to see today that will definitely bridge the gap between what pods are there and what we need in general. All right, so there are a few benefits, and let's understand first what it resolves, and then we'll go towards the benefits. The first is pods share namespaces and C groups by design, so which can sometimes eliminate their isolation. So with nested containers, we can actually add an additional layer which segregates, or you can say isolates, workloads at different layer. When it comes to secure workload flexibility, running Podman Builder inside the pod requires higher privileges. But with nested containers, you can do that without requiring any privilege escalations. There are cases where user wants to actually run VM-like behavior, but with nested containers, you can do that where they can emulate that behavior within the Kubernetes ecosystem. Let's understand some of the benefits of nested containers. It provides the granular namespace management, where the namespace can be handled very precisely, offering better control over the isolation and resource sharing. It also reduces the need for privilege escalation, making workloads inherently more safer. And last but not the least, but very important, multi-tenancy requirement, where nested containers pave the way for benefits of the multi-tenant environments by offering secure isolation at fine granularity. Now we discuss about theoretical part of what nested containers do. Let's understand some pod specs where we see the implication of nested containers in general. So there are 3 pod specs here, and let's go one by one. The first is about privilege pod with rootful container. So what we are trying to do is we are trying to run Podman. It's a container engine inside a pod. So with the first pod, we are trying to use security context as privilege too. So this setup works as is, but there's a catch here. There's a risk here where you are trying to make privilege as true, which might expose host level namespaces and devices. When you go to the next pod spec, which is much better compared with the previous one, where we are using rootless containers, but we are still sticking to privilege true, which is against the security policies if you are going ahead with more pod security context. And last but not the least, but very important, where we are running rootless containers in unprivileged pod. So in this case, we are not at all running privileged pod. We are using rootless containers. We are using annotation. And there's a security, SE-Linux security label that is created especially for running nested containers. You can find that label in container SE-Linux. That is available mostly for Red Hat systems, Red Hat and Fedora systems. So there's one thing that is common across all these pod specs. Do you guess what? Do you want to guess anything? So they are actually trying to solve the nested containerization's basic principle. That is secure isolation, namespace separation, and resource control without privilege escalation. But these pod specs are actually, these are like the workarounds, but this actually expose a certain limitation with the current pod model. So we can discuss this in the next slide. So in Kubernetes, containers within pod share namespaces like sys and proc. And these limit workloads requiring distinct namespaces. There is no per container user namespace for better isolation. Sometimes you try to run privileged containers that might pose some kind of security issues where you are trying to expose pod environments. While rootless containers does work in this case, but you still end up bound to pod level resource and security boundaries. And last but not the least, need for flexibility, where there's an increasing need for more complex tools or build system inside the pod, but that requires better isolation for multi-tenant workloads and needing secure nested environments. You can see the picture here for pod security model. It contains 3 security features: pod security standards, pod security context, and pod security admission. So pod security standard and pod security admission are policy-based mechanisms that govern at the pod level. So it does not involve any process isolation between containers and the host. If we talk about pod security context, with that you can tweak certain security context at the pod level, but it doesn't provide the deeper isolation of UID and GID mapping that the user namespaces provide. And that is where user namespaces comes into picture. That offers a way of security where you can run container process inside the container as root, and you can isolate from the host, which doesn't, if you see the other 3 mechanisms, they don't offer that kind of flexibility. So user namespace provide a functionality that complements, at the same time enhances the current security pod model that we talked about. All right, so now we know the exact limitations with current pod model. Let's shift our gears and talk about some upstream initiatives that we are taking into consideration which not only adds an extra layer of security, but also provides a better solution for nested containerization, which can make it native to Kubernetes. The first one is user namespace support. So this cape we are handling since long time, and currently it's in beta in 1.31, and there is a plan to make it GA in the future release. So one of my colleague, Peter Hunt, is working on this actively. So what it does, like it basically aligns Kubernetes with Linux kernel's ability to run or map container root ID into non-root host ID on the host. So with this, what we are trying to achieve, with this we are trying to isolate user IDs which are running on the container against the host IDs. So for example, with user namespaces, you can run processes inside the container. Those processes can be seen as non-root on the host, and that significantly reduces the risk if container breaks out for any reason. So if you see here, if you go through that enhancement, there are a couple of things that are mentioned where it addresses some of the CVEs if you enable user namespaces at pod level. And that is one of the case why we are pushing for user namespaces in upstream SIG node meeting and probably in the community. All right. Here is the second feature, user namespaces pod security standard. So while user namespaces bring significant security benefits, especially in the multi-tenant environments, and but their adoption needs careful regulation. And that is where user namespace pod security standard comes into picture. It's currently in alpha, but in the later releases, we are going to get rid of it once user namespace becomes GA in Kubernetes. And one of the push for this particular feature is to regulate and standardize the use of user namespace feature in Kubernetes. So it provides a framework that ensures only compliant workloads can leverage its capability. So you can use this feature by setting this feature gate, and at the same time, you need to ensure that there's a node compatibility. So what happens in the downstream Kubernetes, there's an effort going on to have minimum kubelet version. So as an admin, if you're trying to set this particular flag with pod user namespaces flag, you're actually instructing Kubernetes API server to relax pod security context for that particular workload. All right. Last but not the least, but very important feature for actually enable nested containerization within Kubernetes is adding proc mod option. Before 1.29 Kubernetes release, it was a standalone feature, but after 1.29, there was an upstream consensus around making this enable only when user namespaces is enabled within your Kubernetes cluster. So user namespace and proc mod goes hand in hand, but vice versa is not true. Like if you are enabling user namespace, that doesn't mean you have to enable proc mod option. So this feature is beta in 1.29, 1.31, and once user namespace feature goes GA, this will also go GA along with that. So idea behind that is by default, there are certain proc paths that are masked from the container's perspective because it might expose host level and kernel level configuration. So with this particular feature, what we are trying to do, like if you want to run pod or some rootful things inside the container, you can unmask certain proc paths inside the container while maintaining other file system intact on the system. And this is really important, which not only improves the security, but also helps in certain higher use cases like nested containerization and so on and so forth. All right. So here is the user namespace pod, where on the left-hand side, you can see the pod spec, where we kept the annotation what devices want to allow. Then we are going to run rootless container with run as user. We are going to unmask proc mod so that we can mount certain proc paths inside the container. We are going to use container enginety. That's the special SLinux type that is made especially for nested containers. That is available in container SLinux. And last but not the least, but very important, you need to set host users as false so that you can enable pod level user namespace. On the right-hand side, we need to configure CRI-O in order to make sure it works fine. So you need to set the default runtime and the allowed devices, which you already covered in the annotation, and the annotation that we want to cover in the pod. Well, this thing works, but there is a requirement for that. For Kubernetes, you need to use something which is 1.30 plus. And since CRI-O goes hand in hand with Kubernetes releases, so you need to use something 1.30 plus for CRI-O as well. As we talked about container as Linux, you need to use 2.234.1. And last but not the least, Linux kernel, which is 5.12, which has user namespace support. Right. So with that in mind, let's go to demo and see whether that user namespace pod really works. All right. So what I'm going to do here is I'm going to create a local app cluster using the Kubernetes script. And the CRI I'm using is CRI-O. I'll be using the same configuration. And let's see whether it works or not. It got freeze. Okay. All right. So first of all, let's see the CRI-O configuration. I'm using the same CRI-O configuration. Let's go ahead and create a CRI-O instance. Perfect. So CRI-O has spun up. Let's go ahead and create. Yeah. Let's go ahead and create Kubernetes cluster using local app cluster script. So I tweaked that script a bit to make sure it works with CRI-O. It will take some time. So here the idea is to create a pod with that user namespace pod. And once that is done, then probably we'll go inside the pod, see how Podman works. And then we'll see a dummy application running, which will basically prints out the Podman logo afterwards. Yeah, the API server is coming up. It takes some time. Yeah, sometimes you can use this script to create single node and for your development as well. All right, so the cluster is up and running. Let's go ahead and export kubeconfig and see if node is working. Looks good. Let's see the YAML file. I'm going to keep the same YAML file. Let me go ahead and apply that pod spec. All right. The pod is up and running. Looks good. Let's go ahead and exec into that pod. Let's see if Podman is there. Podman got installed. OK. It looks fine. Let's go ahead and run web server. It's almost. So we are going to spin up this web server with that particular image. And I'm going to call for localhost to see if that application works. That's how it is. All right. Do you want to see one more demo? All right. So in this next demo, I'm going to keep the same setup. But in this case, I'm going to spin up one more pod. That would be my application pod. And inside the Podman, I'll be doing a couple of things. And once it is done, then probably we'll see the output on the second pod, the application pod. All right. Yeah. So the setup remains same. We have this pod. Can you see? Can you see like from behind? Can you see the screen? How about now? Looks better. All right. So the setup is same until user NS pod. All right. So okay. So what I'm going to do here is like I'm going to spin up one more pod. That's like an application pod, where I'll be hosting one application, like the dummy application. And through user NS pod, I'm going to change few things for this pod, and I'm going to roll out a different new deployment and see if it works. So here is the pod YAML that I'm going to use. I'll go ahead and apply that pod spec. It's in pending state. Let me forward. All right. Here is the Nginx servers to expose that application. I'll go ahead and apply that as well. Now I'm going to call node IP. Yeah. Can you see here? This is pretty simple application where I'm saying hello KubeCon NA. Now, what I'm going to do, I'm going to change this string to KubeCon India and see if it works. So I'll go to different user NS pod. I'm going to clone that application. Let's do this a little faster. All right, the application got cloned. I'm going to see the current content. I'm going to replace that with sed. And with Podman, I'm going to first log in to Quay, where that image is hosted. All right, so I'm going to build that image because I've made few changes to index.html. And I'm going to push that to my Quay registry. All right, so this is done. Let's see, and I'm going to roll out a new deployment for Nginx one. And I'll wait for it to complete. And let's see if we get that one here. And you get KubeCon. So idea behind this demo is to show you how you can use this local setup to improve your code debug compile cycle. Instead of, so this is something which you can use in integrated cloud environment where you have VS Code and you are trying to kind of play around with certain things. You can actually use this pod and play around with that. All right. Perfect. So, so we have seen the evolution of Kubernetes pods and how the introduction of nested containers open up for some exciting capabilities. So in the future direction, we are planning to stabilize some of the features that we discussed, the upstream ones. So this can be offered in standard Kubernetes offering. And apart from that, we're also looking at enhancing the security and isolation. So it depends on the user feedback and how well they're using that in their development environment. And on that note, in that essence, the future of Kubernetes pod is all about making more flexible, tighter security, and actually using or supporting capable next generation of workloads. And you as the users are the pivotal role in shaping the journey of it. So with that, I want to thank you all, and I'm open for questions. Yeah. Pod. It's a pod level, yeah. You apply to your pod. Yeah. Yes. Yeah. That's why that's there for pod level resource. Like when you mention host users, that you're defining for the pods, not inside the container. So you are running pod under that particular user namespace. Mm-hmm. So that is the one, like you have certain features. With user namespace, you are adding additional layer. Like you are actually isolating UID, GIDs thing. And that is like the additional layer on top of that.
For an example, if I have a pod kind of, let's say, node episode,
Okay.
you need to know about the processes.
Mm-hmm.
Then you need to show all those kind of status of processes.
That's why you need to use proc mode as well. Yeah, that's why proc mode is. So earlier it was only user namespace, but they decided like there are a couple of processes that certain other things need to access, and that's where proc mode option comes into picture, where you can actually use that to unmask certain proc paths.
And with user namespace feature, will we be able to, like for example, if there is host level IPC is configured,
Mm-hmm.
like there are some special kind of pod which are
Right.
static properly to communicate over IPC.
Uh-huh.
Certain things. For those, if we enable user namespace,
Yeah, so user namespaces work only on the process level. It doesn't impact your networking and stuff. That is only specific to process. That's why it isolates process from your host thing. So it will not impact your networking stuff. Networking stack will remain as is.
doesn't bring any additional secret restriction or something like that. It's just for mapping.
It's only for the process, not for networking and other stuff. Any other questions? You can use Docker, you can use Builder, other tools as well. You just need to configure your container file, like the Docker file. So for this container SL Linux, that works only in Red Hat systems. Container SL Linux. So we developed this SL Linux type. So that works only with Red Hat, Fedora, CentOS. I'm not sure about other systems, but to kind of figure out that part. That's the only missing puzzle. But apart from that, if you use that pod spec, it will work as is. Yeah. Right.
When it is mapped to a non-root user or a given user
Mm-hmm.
in the host,
Mm-hmm.
will all the user processes under the top will be available here, or can I still mask it to like further mask only those of the processes which will be communicated? Because basically outside of this container or the container processes
Yeah.
and the process running, I could still be running some other application process on that user which was mapped on the host.
Right.
On the host separately.
Yeah.
Those application processes will also be available as part of
Yeah, absolutely. But that will be non-root.
the user process will still be mapped.
Yeah, that will be mapped in. Yeah. Any other questions? All right. Thank you all.